This is bonding video number 5. By the end of this video, you should be able to state the difference in ionic compounds and covalent molecules. Make sure you have bonding video number 5 worksheet and your pencil available. Our example of an ionic compound is sodium chloride. Now, back from doing our Lewis dot diagrams, we would have shown a sodium ion with a positive charge and no ions, no electrons, and the chlorine ion that has gained the electron now has 8 electrons and a -1 charge. The reason why these two things attract each other is they have opposite charges. The opposite charges allow them to form that bond. And the bond is the same kind of bond that you would see in something that is a magnet. You have two separate ions that come close together because they have two different charges. Now the reality is, since they come close together, but they're not overlapping the orbitals, they're not sharing the electrons, there's no reason why that sodium has to only bond with that chlorine. That sodium can bond with any other chlorine that happens to be around it. And those chlorines can bond to other sodiums. And it continues. As a result, you get bonds not just in the one place, but in 3 different dimensions. This is called a lattice structure. So what is a lattice structure? A lattice structure has some common properties to it. It is going to have bonds in 3 dimensions. It's not going to have just the one bond. It's going to have repeating structure by having those bonds going in all different directions, as long as positive goes to negative, goes to positive, goes to negative. As a result, there's no clear start or end to your molecule. You don't know which sodium gave his electron to which chlorine. After this thing is done bonding together, you have something similar to this. You have the repeating structure with negative, positive, negative, positive, negative, positive, and it repeats on, and you get a cube type of structure. This right here is called your formula unit. This is your simplest ratio of positive to negative charges. It is the exact same thing as your name or your formula. So this is your simplest ratio of positive to negative ions. It is the same formula that you did back when you did your naming unit. So for sodium chloride, it is a 1-to-1 ratio, NaCl. But if something had a positive 2 charge, its ratio would be BaCl2, and that would be his formula unit. The reason why you need it is you have no idea how many sodiums and how many chlorines are in any particular compound because it does repeat. It is a lattice. Now this is different from covalent molecules. Covalent molecules, that should say covalent molecule, would be an example like water. In this case, your bond has shared electrons. The orbital from oxygen has to overlap with the orbital from hydrogen so they can share. As a result, you get a molecule with a very specific bond, and it does not repeat. So if you had more than one water molecule, you would have something like this. Notice you do not have a bond from one water to the next. These things are not connected. Each molecule is its own molecule. You can tell where one starts and ends, and where the next one starts and ends, and the next one starts and ends, because they are not connected. They're their own individual molecules. So as a result, it is going to be easier for you to separate water molecules from each other than sodium chloride molecules, because these are not bonded together, but these repeat the bonds. This is true for any covalent molecule and any ionic one. The covalent molecules do not bond together, They're separate molecules. They're easy to separate from each other. Sodium chloride and ionic compounds repeat the bond over and over and over again until you've run out of positive and negative charges. They are hard to separate.